Hello, boys and girls. Mr. Giumini. You're in capable hands here with Mr. Peltz. I will be back momentarily. I just had to do something real quick, but I wanted to give you some examples and get you started on our next concept here is the distributive property. Now, what's nice about the distributive property is we're going to use it in expressions, and we're going to use it with combining like terms, multiplying, and things of that nature. Stuff we're just building on for what we've done already in a little over a week plus of school, almost going on 2 weeks here. Let me give you an example of what I am talking about. So let's just start with a basic one. Let's just go with something that I guess you guys could do probably using order of operations. 13, we have open parentheses, so there's no sign here, means to multiply, times 10 minus 7. Now there are two ways to solve this problem. One, we'll do it the typical algorithm of following order of operations. We see that we have parentheses. We'll do it in parentheses first. So I'm not using the 13. And this becomes 10 minus 7, which is 3. Now I have 13 times 3, which I believe gives me 39. All right. There is another way to solve that same problem, another algorithm, and we use what we call the distributive property. To distribute, your teachers distribute paper in class. It's just a fancy way to say sharing. We're going to distribute things. Now this also says 13 times 10 minus 7. We could also rewrite it to look something like this. 13 times 10 minus 13 times 7. What does that mean? It means we're multiplying the 13 times each term inside of the parentheses. Remember, a term is separated by an addition or subtraction sign. Ties into yesterday's lesson. Let's take a look at this one. We have 13 times 10. Well, I'm multiplying by 10. I'll just add a 0 on to the other factor, so it becomes 130. Minus 13 times 7. 7 times 3 is 21. 7 times 1 is 7 plus 2 is 9. So we have a 91. Now, taking a look, I think in my head 130 minus 91. Well, 91 is 9 away from 100. 100 is 30 away from 30, so that gives me 39. Look at that. Those two algorithms give me the exact same answer. Now, I'm going to guess that most of you feel that this way is the easier way, the PEMDAS way, where we are not using the distributive property. Now, let's take a look at a problem such as this before I erase this. Let's go to something like this and see how we'd use order of operation for something like this. What if I gave you 2 times x plus 7? Well, all of a sudden now we cannot combine the terms inside the parentheses because they're unlike terms. If this 7 was a coefficient and had the variable 7, then yes, we can make this 8x. But we can't do that. So now I use the distributive property. I like to draw these arrows here. So now I go 2 times the 7 and 2 times the x and 2 times the 7. If I want to write it long ways, it kind of looks like this. 2 times x, operation sign here is plus 2 times 7. Well, 2 times x is 2x, plus 2 times 7 is 14. I cannot simplify this any further. There is my final answer. So yes, order of operations is nice, but when we start to throw variables in there, it's not going to work. We can't utilize that algorithm because I cannot combine like terms inside the parentheses. What if I had something like this? 28 times y minus 1/7. Ugh, fractions. Again, I look inside the parentheses. Y minus 1/7. These are not like terms. I cannot combine them. But what I can do is distribute this 28 and multiply it by each term inside the parentheses. So now I have 28 times y, which is 28y, minus, now let's see how we're going to do this. 28 times 1/7. Now, what I would do is I would actually say, hey, what is 1/7 of 28? Let's take 28 and divide it into 7 equal parts. Or I know that many of you have seemed to show some proficiency with multiplying fractions. I could also do 28 over 1 times 1/7. Now the other starting expression has not changed. It's still 28 times y. Now I could do a little cross reduction here, or I could just multiply straight across. I go 28 times 1 is 28. I go 1 times 7 is 7. This is just another way to say what is 28 divided by 7. So my final answer is 28 times y minus 4. Alright, that is another use of the distributive property. Let's take a look at another one. Let me erase this. Let's take a look at, what if I gave you something along the lines of, let's go with 6 times 4L plus 8, close parentheses, plus 12L minus, let's say we had 16. Okay, now again, I'm going to look inside the parentheses. I cannot do anything inside the parentheses because I cannot combine the like terms. What I can do is I can distribute. I can share this 4 times, or 4L, times 6, and then 6 times 8. So if I want to write this long ways, it'd be 6 times 4L plus 6 times 8 plus, let's bring the other terms we did not use, 12 times L minus 16. Okay, now I can multiply. I can simplify that to give me 24L. So I have 24L is just sitting there. Plus 6 times 8, 48. Plus the terms I did not use yet. 12 times L, where the coefficient is 12, the variable is L, minus 16. Now I'm looking and doing what I did yesterday, combining like terms. 24L's, 12L's. Let's combine those. There's a plus sign in front of that 12, so that means we're going to add 24 plus 12. That gives me 36L's. I now go to the second term that I can combine here. I have 48 and 16. But in front of that 16 is a minus sign, so I'm going to subtract those. So 48 minus 16 gives me 32. Now it is a positive 32, so we are adding 32. It is a positive 32. That's how I would simplify that algebraic expression using the distributive property. If I were to do another one, let's go with 8 times 3m plus 4 minus m, close parentheses, minus 16 minus, let's go with 5m. Okay, this problem here looks a little cumbersome. Not to worry, we can do this. I look inside the parentheses first. Can I combine any like terms? Oh yes, indeed I can. I have 3m's here, and I have an m here, but this m here is being subtracted. So when I combine those two terms, the 8 stays on the outside. 8 times 3m minus m gives me 2m's. Think about it this way. I had 3m's, and it says minus an m. Well, those two m's cancel out, left with 2. Plus 4 minus 16 minus 5m. Okay, cannot combine these two terms. I'm going to work here distributive property. Continue to use that distributive property. So I go 8 times 2 and 8 times 4. So 8 times 2m gives me 16m. Plus 8 times 4 is 32. And now I bring down what I did not use, minus 16 minus 5m. Okay, now I'm going through. I see that I have the coefficient, or I have the variable m. No exponent on that m. I'm looking for another m, another variable m that has no exponent. Ah, I have found it. Now that is 5m. Now there's a subtraction sign in front of it. So if you'd like to think about it, you could write 16m plus a negative 5m. I have 16 plus negative 5. All it tells us we're doing is we're subtracting 5 from this. I am adding a negative. So I'm at 16 on the number line. I'm adding a negative 5 to it. Negatives go to the left, so I go 5 to the left. That would give me 11 m's left. Now I combine my other two terms. I have 32, which is a positive. I know that because there's a plus sign in front of it. Minus 16. And I can do the same thing that I did before. Now I have 32. Combining like terms plus a negative 16. I am taking away 16 from that 32. Well, the answer will still be positive because 32 has a larger absolute value. It is further away from 0 than the negative 16. And I just go 32 minus 16 gives me 16. All right. Hope that helps you out a little bit. Now, what I would like you to do, if I'm going to go to Khan here. That is not Khan. Let's go to Khan Academy here. A great skill that you can work on, and I'm almost positive that I recommended this to you. So I'm going to go to my learning home. Oop, wrong thing there. Learning home, Mr. Giamini. There's the learning home. You will have it over here, but I'm going to search it for myself. It's the distributive property, and I find it right here, and it is factoring numerical expressions, distributive property, and distributive property with variables. Let's click on this one. Distributive property with variables. Taking a look, it says, I'll make this a little larger so we can see it. I'm going to use a scratch pad. It says 1/3 times 3j plus 6. Okay, now I'm multiplying this 1/3 times everything inside the parentheses because I cannot combine the like terms. So 1/3 of 3. If I took 3 and broke it into 3 equal parts, I would just have 1. So I just have j plus, well, what is 1/3 of 6? Again, if I break 6 into 3 equal parts, how much is each equal part? I have 2. Type in my answer. I have simplified that to j plus 2. Hey, I'm correct. Let's look at another one. 7. Now, I don't necessarily like the way this is set up, but I'll leave it as is. 7 minus 4n times 6. I'm going to multiply 7 times 4n and 6 times 7. 6 times 4n, 6 times 7. Now, I'm going to go this way first. 6 times 7 would give me 42. The sign in front of the 4 is a negative or a minus. So let's just multiply now 6 times n. That would give me 24n. Let's take a look and see if we're right. 42 minus 24n. All right. Now, apply right to factor out the greatest common factor. Oh boy, GCF, which we did first week of school, was that? 14k plus 35. The k is going to stay there. I'm looking at the 14 and the 35. What is their greatest common factor? Well, I'm going to look at 35 first. The factors of 35 are 1 and 35, 2 and 7. Are any of those factors of 14? Well, one's a factor of everything. 35 is too big to be a factor of 14. Their greatest common factor is 7. So watch what I'm going to do. I'm actually going to pull out a 7 from both these. So if I divide both of these terms by 7, I am left here with 2k. 2 times k plus 35 divided by 7 is 5. All I've done is divide both terms by 7. And now when I factor it out, it looks like this. 7, open parentheses, 2k plus 5. The reason why I'm putting that 7 on the outside, I still want to show how I am able to get back to 14 times k plus 35. Okay, so that's what I would like you to work on right now. And this skill will be your evening practice tonight. Along with any other one that I recommend, I would work on those today. Okay, have a good one. Take care. Bye-bye.